Hello everybody, this is Miss Piekarski. I'm going to go over the unit circle in this video, and I will cover what a unit circle is, how you fill it out, and what patterns are found in the unit circle. Alright, so let me first talk about the unit circle. So essentially a unit circle is just a circle that you put on a grid. Okay, so this is my circle. I put it on this grid, and you can see how I have these grid lines, but I really don't care what the value is on this grid line because I have, with a unit circle, the radius of the circle, so from the center of the circle to the edge, you can notice all these red lines. Those are all lines, those are all radii of the circle. Okay, so each radius is just 1 unit measurement. It's not in feet, it's not in inches, it's just 1 unit, so hence the name unit circle. All right. And most of the time when you see a unit circle, you don't see a grid because there's so much other stuff on the unit circle to fill out and so much information that you have on the unit circle. And hopefully you guys remember how to convert radians and degrees, because on the unit circle, there's on your thing, there's 2 spots, in 2 lines inside this circle to do the degrees and radians. The one with the little bubble, that's your degree symbol. Just write the number on the line. Then the line that does not have a bubble or a degree symbol, that's for your radians. And what I want you guys to do, use that line as the fraction line. And so you just have your pi on the top and whatever numbers in the denominator on the bottom. And then now I do realize that on some of these, as you go around, you will have numbers in the numerator and the denominator. Okay, so let me just tell you how the unit circle is broken up. So the first thing that happens is you break the unit circle into quarters. So here, just a line straight this way, that's halves, and then a line straight down, your x and y axis. You've broken the unit circle into quarters. Okay, and then let me do my actual lines. Lines are easier to deal with. Now I want that thickness. Let's do orange. Okay, and then at that point, you're going to break it into fours. So each quarter is broken into halves again. So, you know, one half divided by 2 gives you 1/4. So that's the middle line. Okay. So now we have 8 sections. So we have this section, 1, 2, 3, 4, 5, 6, 7, 8. And then you can also, instead of doing each quarter or quadrant, instead of breaking the quadrant in half, you can break each quadrant, excuse me, I can't talk tonight, into thirds. Okay, so, and that's where you're getting these 2 other lines. So this is 1/3 of a quadrant, this is 2/3 of a quadrant, and then 3/3 or a whole quadrant. Okay, so you'll notice that for some of these you're overlapping. So the pink line and the blue lines and the orange lines, you're all overlapping on your axis. So your x-axis, y-axis, you know, those are always overlap, okay? Because when you break each one into halves or thirds, you overlap there. All right, so now let's talk about our numbers, our degrees. So first I'm going to go over the degrees, and then we'll do radians. You know what, let me do the open circle. Okay. So now if you always start with 0 degrees here, okay? And then you have 90 degrees, This would be 180 degrees here. I'll let you guys fill that out on your own. And then down here is 270 degrees. And then if you come back over here, we've already discussed this. We've got 360 degrees. I'm trying to draw 360. So this would be 360 degrees. Okay, so that's if you break it down per quadrant. Okay. And then if you break each quadrant in half, you've got 45 degrees here. Okay, and so you can go around. So the pattern here is that this would be 45. 45 times 2 is 90. 45 times 3, I think, is 135. And then 45 times 4 would give you 180, and so on. So you just keep adding 45 degrees over and over and over again. Okay, and then here you can do basically the same thing, but you're adding 30 degrees over and over again. So 30, 60, 90, this I think would be 120, 30 plus 20 plus, oh my gosh, I can't do mental math and record a video at the same time. Sorry. So this would be 120 plus another 30 would be 150. 150 plus another 30 would be 180. So you're going to, sometimes you'll repeat or you'll land on the same spot more than once. Okay. So you guys can keep going around on your unit circle and finish filling out the different lines for your degrees. And then for your radians, basically you've got the same thing. You guys all remember how to convert degrees into radians. So I've already done some of them for you. So, and I'll kind of review over it again. So you have 30 degrees. To convert it to radians, you would multiply by pi and divide by 180. Well, 30 divided by 180 is 1/6. So this becomes pi over 6 because it's 1 times pi divided by 6. 45 divided by 180 is 1/4. So this becomes pi times 4, or sorry, pi divided by 4. And then 60 divided by 180 degrees is 1/3, so this becomes pi over 3. Okay, so on your unit circle, on these lines, you have your degrees. On the next lines, you have your radians. I know most of you recall that this line here should be pi over 2. And then the same thing with multiplying your radians and multiplying your degrees. You're just going to keep continuing the pattern. So with this one, you have pi over 6. Okay, this would end up, so this is your first pi over 6. Here would be your second pi over 6, but 2 pi over 6 reduces to 1 pi over 3. This would be 3 pi over 6. Well, 3 over 6 reduces to 1/2, so this becomes pi over 2. Okay. So there's 2 ways you can do it. You can find all your degrees and then convert every single degree into radians, or you can just keep multiplying your fractions. So here we had, let's see, 1, 2, 3. This would be 4 pi over 6. Well, 4 over 6 reduces to 2/3. So this would become 2 pi. Whoops, pi should be up here. I almost put the pi in the denominator. Shame on me. All right, so this would become 2 pi over 3. Okay, here you would have 4 pi over 6, right? Let me check my work. 1, 2, 3, 4. This would be 5 pi over 6. I knew I was off by something. That's why I said, as you guys are filling out your unit circle, please make sure you use pencil so that if you have to change it, it's not a major issue. You just erase your pencil markings. All right. And then so you just keep on going around. I would like you to try to get more of your radians, but let's go ahead and move on and correlate our unit circle with our special right triangles. Okay, so the first special right triangle I want to correlate the unit or combine the unit circle with is your 45, 45, 90 triangle. Now, if you remember when we were setting this up, our 45 degrees was right here. Okay, so if you have your triangle, and hold on, let me put it, there we go. And your angle here is 45 degrees, okay? Then, and recall that with our unit circle, the radius is always 1. So here's our radius of 1. And then, so we have our hypotenuse of our 45, 45, 90 triangle, and we need to find the short leg. Well, to find the short leg, you divide by the square root of 2. And we all know that you can't leave the square root of 2 in the denominator. So we multiply by the square root of 2 over the square root of 2. We end up with the square root of 2 over 2. Okay? So this length here, let me change my color. There we go. So this length here, the measurement or the length is the square root of 2 over 2 units. Now remember, this is a unit circle, so this is 1 unit. This would be the square root of 2 over 2 units. And then this length here is going to be the square root of 2 over 2 units. Okay, so because we have because this unit circle is on a grid, this is our x-axis here. Okay, so I could figure out what the coordinates are for the x and y coordinates. So this is our x value, and this is our y value. And because this length here is square root of 2 over 2, then my x value is going to be the square root of 2 over 2. And this y value is going to be the square root of 2 over 2. Okay? Now, we also know that the radius of the circles of our axes, okay, so one radius goes from here to here. One radius goes, whoops, let me change that. All right, so one radius, let me do it in pink. Pretend that's a straight line. This straight line is one radius, and this straight line is one radius. So not only do we know that this point here has the x value of square root of 2 over 2 and the y value of square root of 2 over 2, but we also know that since this x value here for this line is, the x value is 1 and the y value is 0, and then all the way up here, our x value is 0 and our y value is 1. And if we kept on going around, okay, all the way over here, this time our x value is negative 1 because we're on the negative x-axis, and the y value is 0. And because this 45, 45, 90 triangle can flip or rotate, my x value here is actually, I should have a negative sign here. I forgot my negative sign. Shame on me. So this one would be negative square root of 2 over 2, because that's negative x. And this y value would just be square root of 2 over 2. Okay, so now this 45, 45, 90 triangle, it will keep on going down here, and you can find every single x and y value that's in increments of 45 degrees. Okay, let's look at our, let me see, 30, 60, 90 degree triangle. Same basic principle. Our angle, our rotation angle or our reference angle here is 60 degrees. And if my radius is 1, then I divide my radius by 2 to get my short leg, which happens to be my x value here. And then if I have my short leg, I multiply by the square root of 3 to get my long leg. Okay, so now for the x and y value This is my y side. This is my x side. So my x and y value here would be 1/2 and the square root of 3 over 2. It's my y value. Okay, now over here, notice I forgot my negative sign again. Okay, so x is negative, y is going to be positive, same results, just negative and positive. So now I have a negative 1/2, and I have the square root of 3 over 2. Okay, and then the ones down here, same thing, all the way down here. You guys can fill those out as well. Okay, and then the last one, so I have a 60-degree angle here. Well, I can rotate my 30, 60, 90 triangle so that I have 30 degrees here. Okay, notice my side values, my long leg, I still have the square root of 3 over 2 on the long leg, and I still have the 1/2 on the short leg, but this time this is my y value, and this is my x value. Okay, and so y becomes 1/2, and x becomes square root of 3 over 2. Okay, so you'll find that all of the x and y values that are on the axes are going to be whole numbers, and all the x and y values that are in between the two axes, so they're inside one of the quadrants, you're going to have fractions. Okay, so that's why these lines are like halfway, they're centered between the parentheses, and then these ones are on the bottom of the parentheses. Okay, all right, so what I want you guys to do this weekend, go ahead and fill out this unit circle. Make sure you fill it out in pencil. There are tons and tons of resources online that you can check your work and make sure you have all the correct answers. Some of them like to have decimals here instead of fractions. Do not give me decimals. I want exact answers. Hopefully everybody knows by now that Miss Pie wants exact answers.